Welcome to a brand new series on the DotNet Way. We are thrilled to launch Crushing Design Patterns in .NET Core, your ultimate guide to writing clean, scalable, and professional C# code. And we are kicking off the series with the absolute foundation of all great software design, the solid principles. Are you tired of stumbling through design pattern questions in C# interviews? In this very first episode, we are going to dive into a real-world interview scenario, arming you with the practical insights you need to master Solid and stand out from the crowd. Let's see how our expert Arohi tackles the challenge. Arohi, welcome. In today's scenario, we need to design a notification system for an e-commerce application. Initially, it only needs to send an email when an order is confirmed. However, the business has plans to add SMS and push notifications in the future. Let's begin. What is your initial high-level approach to this problem?
My entire approach would be guided by the solid principles to avoid building a rigid system that's hard to change later. The key is to start with a design that anticipates change. Instead of writing one big class to handle everything, I'll focus on creating small, decoupled components that each have a single, clear purpose. This will make the system maintainable and scalable from day one.
Let's apply that. How would the single responsibility principle, SRP, guide your initial classes?
The SRP states a class should have only one reason to change. So, I would immediately create an email service class. Its only responsibility would be the technical details of sending an email, connecting to an SMTP server, or calling a third-party API. It would know nothing about order details or what triggers the notification. This way, if our email provider changes, the email service is the only place we need to look.
How does the open-closed principle, OCP, prepare this design for future requirements like SMS?
The OCP is critical for scalability. It says we should be open for extension but closed for modification. To achieve this, I'll introduce an abstraction. I'll create an iMessage service interface with a common send message method. Our email service will then implement this interface. Now, when we need to add SMS functionality, I don't touch the existing code. I simply extend the system by creating a new SMS service class that also implements iMessage service. This is the essence of the open-closed principle.
How would a higher-level service use these different implementations without breaking the Liskov substitution principle, LSP?
The LSP ensures that our abstractions are reliable. It means I should be able to use any subclass of iMessage service without the calling code needing to know the difference. I'd create a higher-level notification service that depends on our iMessage service abstraction. Here, the notification service can be given an email service, an SMS service, or any future message service. As long as they all correctly implement the send message method, the system works perfectly. The substitution causes no errors.
What if the business wanted to send both email and SMS for certain orders? How would your design handle that?
That's a great follow-up, and it's where dependency injection really shines. Instead of injecting a single iMessage service, I would modify the notification service to accept a collection of them. In my program.cs, the DI container would automatically inject all registered iMessage service implementations. This design handles the new requirement without any complex logic in the notification service itself.
Let's consider a new feature, scheduled notifications. How would the interface segregation principle, ISP, prevent a bloated interface?
The ISP is all about keeping interfaces lean and focused. It would be a mistake to add a schedule message method to our existing iMessage service because not all services, like SMS, might support scheduling. This would force them to implement a method they don't use, which violates the ISP. The correct solution is to create a new separate interface, iSchedulable message service. Only the classes that can actually perform this action, like a future push notification service, would implement this new interface. This keeps our design clean and avoids forcing unnecessary methods on our classes.
What is the role of the dependency inversion principle, DIP, in this entire design?
The DIP is really the foundational principle that makes all the others work together. It states that high-level modules should depend on abstractions, not on low-level concretions. My high-level notification service, which contains business logic, never knows about the low-level email service, which handles technical details. They are completely decoupled. They both depend on the iMessage service abstraction. This inversion of dependency is what gives us our flexibility.
How do you manage the configuration, like API keys or server addresses, for these different services?
That's a critical operational question. I would never hard-code these values. Each service would have its own strongly typed configuration object, following the options pattern in .NET Core. For example, email options would hold the SMTP server and port. These configuration sections would be defined in appsettings.json during development.
How do you secure these configuration secrets in production?
In production, appsettings.json is not secure. I would store all sensitive secrets like API keys or connection strings in a secure secret manager. The standard and best practice in an Azure environment is to use Azure Key Vault. My application would be configured with a managed identity to securely access these secrets from the Key Vault at runtime, ensuring they are never exposed in source code or configuration files.
Finally, how does this solid design make the system more testable?
The testability of this design is one of its greatest strengths. Because my notification service depends on the important service interface, I can easily write unit tests for it. In my test project, I don't need a real email or SMS service. I can create a mock miscellaneous service object using a framework like MOQ or NSubstitute. I can then pass this mock object to my notification service and assert that its session method was called with the correct parameters, without ever sending a real notification. This makes my tests fast, reliable, and completely isolated.
Arohi, that was a masterclass. You've not only solved the problem, but have perfectly demonstrated how the solid principles are the bedrock of every great design pattern. This was the perfect way to kick off our new series. If this deep dive into Solid has prepared you to crush your next C# interview, then you are going to love what's coming next. Make sure you've given this video a like and comment below with which Solid principle you find most challenging. Most importantly, subscribe to the .NET Way and hit that notification bell, because in episode 2 of our Crushing Design Pattern series, we will build on this foundation and tackle one of the most powerful patterns in C#, the strategy pattern.